Hello, in this tutorial we are going to look the process how we can find out cut length of bent up bar. Okay, so let's get started. This is basically in metric. So first of all we will look about what is bent up bar. Now bent up bar is also called as crank bar and it is provided to make RCC slab safe from compressive stresses. Okay, so this is all about the bent up bar, and this is the visual interpretation. You can see here, this is basically the bent up bar. It is just starting right from this position at the top and it is going at the bottom. Okay, let's suppose we have beam over here. Okay, on the top of this beam, this bent up bar is going to start, and then after some span, it could be L by 5, L by 4, okay, according to design, it is going to go here at down on the slab. Okay, and again it is moved toward this direction. So if we have two side bent up, it will just like this. Okay, right from this position we have beam. Let's suppose it is going here and it is starting at the top, then it will go here at down, then it will go here, then it could be go here, and then again here if we have beam at this end as well. Okay, so this is basically the bent up bar. Now let's look about some zone portion over here for the bent up bar. Let's suppose we have this slab, okay, and this is total of 150 mm thick right from this position up till here, and this is the bent up bar that is starting right from this position. It is going here at down. Okay, and here we have some of the details like dia bar is 12 mm. Okay, and I'll let you know about what is this H. Okay, concrete cover is 15 mm. Okay, at both ends, at bottom and the top as well, and dia is 12 mm again. So we will look this portion again. Let's move forward, and here we have some of the given data for the bent up bar. Okay, and according to this we will find out the cut length. Okay, let's suppose the thickness of slab is 150 mm and the dia that we are using in 12 mm. Clear span, in to in span I'm saying over here. Okay, clear span mean in to in span between two supports. It could be beams or the columns. Okay, it is 12 mm. Okay, and then sorry, it is 1800 mm. Okay, this one, and slab thickness is 150 mm and clear cover, okay, mean concrete cover is 15 mm and the bend length is 12D. This is the hook that we are using over here, 180 degree, it is 12D. Okay, so this is basically the given data. Let's find out the calculations for the cutting length of this bar, and for cutting length this is a formula: clear span, okay, right from this position up till here, this is a clear span. Okay, and next to it we have crank length. And what is crank length? In clear span we have took this dimension. This is basically the crank right from this position up till here, this is crank. Okay, and in clear span we have took this dimension right from here up till here, this horizontal dimension. Okay, if I draw an arc over here, the remaining part is this one, and this is basically we need to find out through this formula, 0.42 into H. And remember, if the angle is 45 degree, then we will use this one. Okay, so this is the portion that we will find out, and this whole is called as crank length. So what is this? Clear span into in span plus crank length and plus breadth of beam. Okay, this one plus this one minus concrete cover. Okay, because we need to deduct concrete cover at this end in order to meet the requirements, and this end as well. Okay, and 2 into bend length. Okay, we have two hooks over here, so 2 into bend length minus we need to do the bend directions as well. Okay, so here if the angle is 45 degree, then we have 1D for 45 degree into number of bends. So number of bends will be 1, 2, 3 and 4 bends. Okay, minus 4D for 180 degree. If the hook is 180, then we will take 4D into number of bends. Okay, so now for 45 degree it is 1D and for 180 degree it is 4D. Now clear span we know it is 1800. Next to it we need to find out the crank length, and the crank length we have two cranks, this crank and this crank as well. Okay, so the formula is 2 cranks multiplied by 0.42 into H. Okay, and what is this H? This is very important to understand what is this H. So let's take some zone portion over here for the crank bar, and let's find out this H over here. Okay, this H is basically the total thickness of our slab, okay, minus concrete cover at both ends, this end and this end as well. Okay, 150 minus 15 minus 15. Okay, then what we need to do is we need to deduct half dia at this end for this bar and half dia at this end from this bar. It will give us the H value, and this is the H, 108. Okay, so let's move again over here. So H will be equal to slab thickness minus 2 into concrete cover, as we have seen earlier, minus dia of bar. Dia of bar mean we have half thickness, half dia at top, half dia at bottom, it will make full dia. Okay, so 150 minus 2 into 15 mean 30 minus 12, 6 plus 6 will make 12. Okay, and the H is 108 mm. Okay, what? 108 mm. So crank length will be equal to 2 into 0.42 into H, and this is basically the length right from this position only up till this position, because this portion we have took already in the horizontal case. Okay, this case, so this is basically length of crank, 0.42 into H into 2, because we have 2 cranks. Okay, and remember one thing, if the dia is 45 degree, then we will take 0.42 into H. Okay, but if the crank dia is 30 degree, then we will take 0.27 into H, and if the crank dia is 60 degree, then we will take 0.58 into H. So these are some cases. Okay, according to your drawings you can take all of these values. Okay, so hope you understand what is crank and how we can find out it. Now breadth of beam minus concrete cover. So we have 2 beams. Okay, and the dimension is 300 minus concrete cover, and 2 into bend length. Okay, 2 into bend length, this hook length basically. So it is 12D. You can see over here in the given data, 12D. 12 into D is 12 mm. Okay, and then we need to do the bend deduction. So we have 45 degree bends. Okay, 1 into dia bar into number of bends. So we have 4 bends. Okay, and 4 into dia bars, and we have 2 bends for 180 degree, this one and this one as well. Okay, now let's put the values over here. 1800 plus 2 into 0.42 into H is 108, plus 2 into 300 minus 15, plus 2 into 12 into 12. Okay, this is basically the bend length, plus minus we need to do the bend deductions, 1 into 12 into 4. Okay, and 4 into 12 into 2. So the total answer, okay, the total length for this crank will be 2604.72 mm, or in meter it is 2.604 meter. Okay, so hope you understand the process how we can find out this crank length. Okay, in millimeter and the meter as well, we have done in detail in FPS system in feet and the inches. Hope you understand the process over there as well. Okay, and if you think the repetition is going on, you can move forward. Okay, in the bar bending schedule lessons. Okay, for basement, for the columns and the beams and the slab. Okay, in detail, so you can move forward over there. And if you think you need to just go through these lessons as well in matrix system as well, so you can watch all of these video series as well.